Hello, this is Sigma Bob. In this video, I will be discussing problem 24 from the AMC 10 2024A. We will carefully examine the problem statement, identify the key idea required for its solution, and work through the steps in a clear and systematic way. Let's get started. Here is problem 24 from the AMC 10 2024A. A bee is moving in three-dimensional space. A fair six-sided die has faces labeled A plus, A minus, B plus, B minus, C plus, and C minus. If the bee is at the point ABC, then A plus moves the bee to point A plus 1 B C, A minus moves the bee to A minus 1 B C, B plus and B minus change the second coordinate by plus or minus 1, and C plus and C minus change the third coordinate by plus or minus 1. The bee starts at 0, 0, 0, and the die is rolled 4 times. What is the probability that the bee traverses 4 distinct edges of some unit cube? We break the path into cases based on the bee's third move and count the valid fourth moves that keep all 4 edges on the boundary of a single unit cube. Pause the video here if you'd like time to solve the problem yourself. Now, let's go through the solution. Without loss of generality, we can fix the first two moves, since every orientation is symmetric. The first move always lies on an edge of one of the 8 unit cubes surrounding the origin, and after that, the second move has a 4 out of 6 chance of staying on one of those cubes. Now consider the third move. There are 2 possible ways to remain on the boundary of the same cube. In the first case, the bee moves to the corner of the cube farthest from the origin. This happens with probability 2 out of 6, and from there, only 2 of the 6 possible fourth moves stay on the same cube. In the second case, the bee stays on the same coordinate plane, ending at a point that is still 1 unit from the origin. This occurs with probability 1/6, and now 3 of the 6 possible fourth moves keep the path on the cube. Adding these two cases together and including the probability of the first two moves gives 2/3 times in parentheses 1/3 times 1/3 plus 1/6 times a half. Evaluating this expression gives the probability 7 out of 54, and the final answer is choice B, 7/54.